Hello and welcome back to Satisfactory. I am going to try to go over the design of a blueprint to embody the fluid loop implicit in the plastic factories. Sorry, I'm a little distracted here. Where to go? There it is. Sometimes I get an extra tilde out of my keyboard. I don't notice that the console is open. It's like, why isn't it doing stuff? Like that. Come on. What I want to do is open up my editor and bring up my plan here. I know that people do better with this complicated stuff if they can actually see the recipe on the screen. There's the recipes. So you've got Alumina Solution, which takes in bauxite and water and turns out alumina solution and silica. Straightforward. Then you've got the other refinery, which is aluminum scrap, that takes in the alumina solution plus some coal and turns out aluminum scrap and some water. And this returns 1/3 of the water used to make the solution. Okay. Now there's all sorts of ways of combining the recycled water with the fresh water coming in. And I spent a bunch of time in Update 8 fighting with the variable input priority merger for pipelines to try to get that work. Got it working perfectly, and then found out that it is prone to deadlocking if your input starved in other areas. So I thought, can we do this without merges? And it turns out that yes, you can. And the second thought was, gosh, wouldn't it be nice if I could do the two? Basically, it's 1/3 of my water is coming from the recycled. So what if I have 3 refineries, 2 taking from outside fresh water and 1 taking the recycled water? Great. You could do it with 2, but you have to cut the quantities way back because 2/3 of your production has to happen in 1 refinery. So that works. And we're 5 wide here. And refineries just happen to just fit 4 of them all the way across. So I could do this. We can fit that. That's just to show that it fits. Now I am going to raise them. Notice over there what I've done is I've put my machines on top of a sandwich layer. This works really well if you're going vertically, but if you're putting everything at ground level, it would be really nice if I countersunk that by 4 meters so that this layer here is what you walk onto and all the belts are hidden. So I'm going to assume this is going to be countersunk. Secondly, I am going to countersunk twice. I'm going to have a sub-layer that has all the belts. Put the machine back out there. Look at it from the side. We've got a bunch of framework there. Well, what if... let's pick... Come on. You. Builder. Foundations. What if I just take a foundation like that? Boom. Okay. Is that too much? Let's layer that in 1 meter at a time. See how much I want to obscure. This is basically, I'm learning from what Fluxo did. That's not bad, but we still can see the top of inputs over here. I'm going to put a 3rd meter on this. So if I do it like that, that's actually not bad. So it's going to be 3 meters to hide this. I don't know whether the seven. I don't know whether the top there is going to do that for. Let's see how many of these it's going to take. So we to vertical node 6, 7. Yeah, that should hide it. What we'll end up with is a floor that looks something like that when we look underneath it. Okay. So the area underneath where I'm going to put my belts, that's going to be a standard sandwich layer. So let's put the top of the normal sandwich layer in. This is at the level where if I pass a lifter through a hole in this layer, its minimum clearance causes it to be putting the belts on its bottom layer. So it's the same base levels I've been using over there. Now the difference is I am planning on countersinking this in the destination, so I will not be putting on walls. We want our refineries to be sitting on top of that. So let's put our 4 refineries back. So center it all the way back like that. We're going to take our water input from the right. I want to place that. So 3 of these are going to be doing the Alumina Solution. So I'm going to start off with the middle ones. Like that. 2 of them are going to get fresh water, and 1 of them is going to take from the aluminum scrap. So I'm thinking we'll leave a gap. We need a gap in the fluid. So if the fluid is here, I turn this guy around. That. Now we've got some space between his water input and his water output. And you're going to be doing aluminum scrap, turning out 120 water per minute. We're doing Alumina Solution, taking in 180. We're going to have to, oh, right. I forgot. When you're doing this way, this guy has to go to 150%. You either clock this guy up to 150 or clock these guys down a bit. Either one works. I may even instantiate this in a smaller context where these guys are all running at 50% and he's running at 75. It's okay. Scale the whole thing up and down together, and the fluid loop that we're going to design is going to continue to work. But we'll leave him scaled up and these guys normal for now. So 180 water coming out here, 180 water coming in, 180 here, and 180 here, so that's going to be 360 water coming in total, guys. I want to bring the water in from the side. So let's put this guy right on this center line. This is going to caught that. And that puts a ring right in the wall on the edge of the blueprint. So we know that's where our water is coming in. Water is coming from. Now these two, it's going to be that water pipe coming there, but it's still water. I'm going to put it on the same line, like that. Consistency is good, and we have a lot of space here. I mean, 5x5 turns out to be a lot of space for this, even though it's not a lot of space this way because these are packed next to each other. We certainly have enough space to take take a breathing space here and put this so that they out nicely. Water, water, and water. Now, most feedback systems are somewhat like this, except they also have some way of moving water between this loop, that loop, and it's possible to get that working. I've fiddled with VIP junctions. You'll see those mentioned. Basically, that's you bring your recycled water in on the level and you drop your fresh water in from the top, and that's a priority scheme. The recycled water moves first. That's great. The problem is, once you get that working, it works beautifully until you get input starved. And you can end up in a situation where all of your factories have full output tanks. Okay, so you look at this guy, and he has a certain amount of water that he can build up in his output. If that gets full, you can't run. So if everybody has full tanks of their output, nobody can actually produce anything. So I tend to not like it. There are other ways of doing it. This is called Mergeless because I am not merging the recycled water with the main water. When I am doing those, I'm putting a fluid buffer in here. Let's center the fluid buffer between the two machines. This is a nice clean line here. That's because we're not producing fluids at a nice steady pace. We're not getting every 1/10 of a second a certain fraction of it. What we're getting is occasionally it dumps a bunch. And that is that this machine, every second, it's adding 2 cubic meters of water. That's pretty steady. This guy, every 6 seconds, it consumes 18 cubic meters. So bursty. So what we're going to do is we let the water flow into the fluid buffer. Whenever you want to output some, it pushes it into here. And then whenever this guy wants to input some, it takes it from there. Now, you can have this in this can basically end up in 3 things long term. We can either long term end up with it in steady state where generally this is empty. And if it's empty when I want water, I'm going to wait. And if I end up waiting, that will mean the next time around, by the time I'm ready for it. But once I get my water from there, the next time I come to get it, it'll have water. If it's full, that guy over there will wait briefly to let me pull some out. And then the next time around, I will have pulled out. So this should either be pulsing near the top or pulsing near the bottom. I don't know if there's pressure effects. If there's any sort of pressure gradient affecting the rate at which you can pull water, this may end up bobbing around the middle or at some level, which we can calculate if we knew how it worked. I was tempted to put the industrial buffer in, but I don't think it fits. I would have to have just the industrial buffer and maybe, I don't know, maybe we could try that. I'm not sure there's room here. The other fluid is the easy one. Basically, all 3 of these guys are going to be outputting 120 Alumina Solution per minute. Again, I'm going to bring it out to this midpoint. we're not actually producing this as output, but use the midpoint on the other end, and there's no good reason not to. And we got a long gap between the producers and the consumer, and that's a really good place to put, guessed it, another fluid buffer. Get this hooked up with the Mark II pipes. So you generate 120 a minute, you and you. And of course, this guy, because he's overclocked, he's going to be consuming 360 a minute, which is why you need 2 pipes here. But if it was only 300, I still wouldn't use Mark I pipes. I don't like running pipes at exactly their rated throughput, because any bobble anywhere in the system will cause the whole thing to slow down instead of, temporarily go a little slower and then go a little above. What you want to be able to do is with the fluids, you want to be able to exceed the rated capacity briefly. Now the solids we're just going to take down into the subfloor, up from the subfloor. I'm going to bring them down very tight because I think that looks best. Feel free to do these to your taste. You've got all the room in the world. You can bring it out here in the middle if you want. You can have the outputs going even on a brief belt and going down if you want. They've got a lot of room. So here are the output of him, or the input. So for the inputs, we reverse the direction, get the blue arrow. So we are providing there. I like to raise the guy to check the color, and then you bring it back down. You feel it snap in before you actually get to it. This side is done. Well, that much. Here, and the same thing. This is an output. All outputs. E is an input. Now the next step is raising the floor here. I ought to be doing this on site so that I can briefly stamp this down and provide it with all the goodies, which if I was doing it on site, the first thing I would do would be to go acquire the bauxite and the water and the silica and all of that stuff. This, again, giving me a whole bunch of tick. I'm wondering if there isn't crosstalk between my keyboard and my wife's keyboard because we're using the same keyboard. They should be on different channels, but what can I say? Logitech, right? Normally good work, but I am not sure that they're very projecting stuff. So these three are together. So these are outputs. I'm going to bring those out the back. I'm going to shift this to using the Bluetooth on the here. See if I still get the extra keystrokes. It's not giving me keystrokes as she's typing it. That's clear. I mean, she's over there doing stuff like crazy. And she's certainly not holding down the tilde key. There's my output. And this is an input, so he's going to have to snake over that direction somewhere. This is an output. We'll just set these up like that. They're going to have to do-si-do. And this is an input, so it comes from the front. That. Splitter. we should have visible here. We should have this guy. The rest of this can be buried underneath foundations. And I want walls on the outside. But really what I want flooring to be this level. Is that correct? No, I want it one level higher than that. And because all this is going to be buried underground, because it's all going to be countersunk, to just trace all of the 1 meter foundations that are at this level. I don't need them anymore. Also means that if I wander into the sub-basement, I'm going to have visibility to all of the connections all the way up. Cool, huh? Let's get the actual ground level floor in. Where'd my water input go? Oh, I need to color this. So this is Alumina Solution. Uncolor that. Make sure, yep, that's the solution. At this end. 3 machines are making Alumina Solution, so I'm going to light. Now this one's for aluminum scrap. I'm not going to color him because the color would be very near the Alumina Solution. I really want it. I value the contrast. On this side, you have the weakness that our input here is not at one below ground level. It's like on the edge of ground level. That just a little bit weak. What can I do here? Good. Take from you. Put you in horizontal or vertical. Straight down. You're going to be at the same level. Solid. That. I could bury a pump in here as well to keep this well pumped. Eating from below is not generally a good thing, which is why I am going. That. Okay. So, electricity. Guys, take their electricity right in their midpoint. I'm going to just bring it right down like that. This guy's on the side. What? got them reversed. Be sure it would hide the wires and everything. Come on. This guy has it on this side. Got it. We say power. Right there. And I'm going to connect you to set from the corner. So we're going to use the normal corner thing that I've been doing in all of my blueprints. Once these blueprints are placed, something I haven't been doing, once you've finalized where it's placed, you've got it the neighbors set up and all of that. You don't want the corner holes. You can just delete them. They're only connected to the one nub underneath, not needed for anything else other than connecting us to neighbors, main power. Or in the case of one of my blueprints, a convenient place to patch the fact that I missed some connections. So all of our corners are there. Doesn't have power done. Three have there yet. Placing this is going to be a little tricky. I have to get a countersink, so I've got whatever my floor level is. You have to go down just the right level and place a concrete slab below that. So this goes on top of the concrete slab and comes up with just the right level. That'll take some experimentation, a little bit of try and fit, but on the other hand, this is enough to handle quite a lot of aluminum factory. So we may only have the one. How does that look? That looks pretty decent. Got our power cables coming in. Ladder here we can climb to go up to the top. Scrap. And Alumina Solution. Solution. And Solution. So they're programmed. They've got their power run. They've got their fluids run. Got their solids run. So I just need to get the input and output solids routed to the outside. We've got the water set up. Color it. The native blue. Oh. You need power. If you have an unpowered pump, it resets the head lift to 0. So if I didn't power him, the water would stop here. Would not be able to go up. Now, it's tempting to have the recycled water have a slightly different shade of blue so you can tell which one's recycled and which one's fresh. Don't think it's important, especially since it's all hidden. Now, the other thing I want to do is I want to start putting signs in. This is water input, and we need 360 water per minute. So I'm going to put in a sign. Oh, if we're going to put a wall in, okay, we're not going to put a wall on it. If we were going to put a wall in it, we would have a problem because we wouldn't be able to have the sign mounted. Meanwhile, let's see, I want sign of this. Cable sign 2 meters. Can't go right on the edge. Into there. Raise them up to here. That. Next to the sign. This is going to be 60 per minute water. Real simple sign. We're going to leave off all of the walls. I'm going to leave off the pipeline support. I'm going to try to make it so that nothing goes outside the walls. Back. Oh, I clipped this into the middle of the pipe. So, important thing, if you have placed a junction or a pump onto a pipe, 2 halves of the pipe meet in the middle. That's a cause for bugs. Or at least it has a reputation of being a cause for bugs. And the way you fix it is you remove the 2 pipes that are touching in the middle. You rejoin it. So now if I mark those 2, you can see that they are not touching each other. So there's no confusion about which way everything goes. Sorry, I should have been more clear about that. And with this, I think I can take this sign and put it down below. Yeah. Builder. Label sign. And I can bring it to the half meter point. Yay! Now, I can, in fact, delete that sign once I put this into place. I can delete the sign so that it doesn't clip into the pipe. So, outputs on this wall, puts on this wall. These 2 need to avoid each other. Just to turn them. And up like that. This guy will have to make a last minute adjustment to get all lined up. That puts it on the center line so we can take that out through a wall with a hole in it if we want to. And I'm going to delete this last little bit. And we're going to put a sign there. Now this, coming from here, but this is 540 aluminum scrap per minute. So this is more scrap than we could put on this belt. So I will need to scale this down when I actually implement. So let's just do it. Okay, so you are going to be at 100%. These guys need to be at 2/3. You accept 240 per minute of alumina. Divide that by 3. 80 per minute. So each one of these needs to be scaled to produce 80 per minute. Of course. So 80 per minute, we're doing 360 aluminum scrap per minute out the back. That looks really bad. Yeah. Make my text smaller. I think I have to go to a wider sign. That works. I already have a sign for the water, which is now wrong. It's going to be 120, it's 360 water. What? No, it's going to be 240 water. Right. Because it's 2 of these get their water from the fresh water. Which means that in theory, I could run this on Mark 1s. So that was with Bluetooth going. I think I just have some sluts in my Delta key somewhere. You know how keyboards are. Output from here. Let's put our. This is an input. By dragging it from there to there in straight mode, it comes out straight as far as it can, and then it makes the double. I am going to again get deleted. I was going to use the bigger signs, wasn't I? This is bauxite. Need enough for 3 of these guys. So 80 is going to be 240 bauxite per. Other input, this guy. Same thing here. Comes from there. Clears its curve as long as possible. Ends up. This is the coal. So we need 120 coal per minute. and use Control and the arrow keys to nudge in the smaller increments. One's which? Back to that's regular. The coal input, bauxite input, water input, scrap output. This is silica byproduct. We're going to come to here. Total silica is 33 1/3 by, that's 100 silica total. There you have it. So we've labeled our print, so we have our stuff all set up. We know what our inputs are, what our outputs are. We have our that guy. We're going to countersink this to be level so that we walk on above the level, so everything below is just kind of in the basement. We have a pump on our water to bring it in from here and pressurize it up into the machines. So that should keep that going neatly. I think this is ready to go. So I am going to call this simple aluminum refinery making Alumina Solution locked. 2/3 feeding one refinery being aluminum scrap. Recycled water is not merged with fresh water. I think that's all we need to say about that. Select the icon. I'm going to select the icon aluminum scrap, because that's our goal, is to produce aluminum scrap. And now, if I place it somewhere, it's going to be a 5x5, so all these 4x4 pads I've got are kind of not be big enough. Let's see if I can put it over. Now, if I try to, I can do a mode blueprint. So mode blueprint would center the 5x5 over the 4x4 that's there. And you have to give it a moment to make sure all the belts are connected and all the pipes are connected, and we will have weirdness around the legs, and that's okay, because since there's nothing for them to sit on, so it kind of drives them down, but we're in a basement, so we're good, right? And I think that's it. So I'm going to call this a recording. Let's make sure one more thing. Powered up. Everything should light up yellow. Yes, it does. Good. It's not a full test, but at least we know we're sort of working. I may put that lower floor in, get rid of those pylons coming down. I don't know. Anyway, I'm going to make this a nice short recording and cut it off for now and start working on gathering all the materials we need to feed this and set up for what I want to do with the aluminum scrap when it's done, because that's the next parts here. We need to get our bauxite in. We need to scale this based on how much bauxite we've actually got. And then once we've got our scrap, we need to get our water and our coal in. We need to go make ingots. Some of those ingots are going to be using the silica that we produce here. Others will be consuming fresh silica we're going to add. We're going to do the same thing. So we're not going to mix the recycled silica with the fresh silica. And that goes into 12 assemblers making all-clad aluminum sheets, which is going to be a big whole cube. But we already have the blueprint, the 4x4 blueprint with 3 assemblers in it that we can use. So we are well on our way. I will go get the other stuff going in the area where we're going to put the plant, and we'll see about building it in the next recording. I will see you then.